In this section on domain and range, intercepts and zeros, our objective is to be able to investigate and analyze functions and their characteristics graphically, including domain and range intercepts and zeros. Let's begin by reviewing what domain and range mean. Domain is the set of all inputs of a function. We can call it the x values, the independent variable, or the cause in a scenario. The range is the set of all outputs of a function. We can call it the y values, the dependent variable, or the effect in a situation. Let's begin with some examples of finding domain and range. Write the domain and range of each function. So looking at this graph, remember that this is the x-axis, let's label it, and this going up and down is the y-axis. Let's label it. Because when we see domain, we're going to think of the x, and the x-axis goes right and left, we're going to see how far left does the graph go. And I see how far left it goes is -3, and how far right it goes is 4. So taking how far left it goes, -3, and going to how far right it goes, +4, there is the function kind of flattened out, you could think of. It goes from this point to this point. So the way that we write what the domain is, it goes that way and that way, is squiggly notation. This is set notation. We say all x such that, and then because there's two endpoints and the function is everything between those, we're going to say -3, starting with the smallest value, is less than or equal to x, which is less than or equal to 4, the biggest value, and the set notation. So the domain, that's our x, is going left and right like the x-axis. Then we'll look at the range. The range is the y. The y goes up and down. See the y-axis going up and down? So we're going to see how low does this graph go, and it goes to -2. So the point, we're going to drag it off to the side, -2. How high does the graph go? I see the graph stops here at +1. So we're going to take it up to +1. And this is the y values. Like the y-axis goes low to high. So from -2 up to 1. So just like we did for the domain, we're going to say it's all y values such that, and because it's between -2 and 1, we say -2 is less than or equal to y is less than or equal to 1. Close the set. Let's take a look at one that might look a little bit more complicated. Again, domain, we think of x. And remember our x-axis goes right and left. So how far left does this graph go? The farthest I see in the graph is here, 1, 2, 3, -3. And the farthest to the right that it goes is here, 1, 2, 3, 4, that's +4. The graph is everywhere in between that. So it's like our x-axis going right and left. So it's my domain, all x values such that -3 is less than or equal to x is less than or equal to 4. Now let's look at the range. The range is the y values. Y is the vertical axis going up and down. So I look how far down does the graph go. It goes as low as 1, 2, 3, 4, 5. That's at -5. How far high does the graph go? 1, 2, 3, 4, 5. It goes all the way up here to +5. So the graph goes all the way from -5 up to +5, just like the y-axis going up and down. So I'm going to say all y values such that -5, I start low, is less than or equal to y is less than or equal to +5. Example C. The domain is the X. The X-axis goes right and left. So I'm looking at how far left does the graph go? Well, when I see an arrow, there's no stopping point. There's no end point. The arrow means go forever in that direction. How about to the right? I see an arrow again. So it goes to the right forever. So when it goes forever to the right and to the left, we say for the domain that it's all real numbers. There are no restrictions. It's everything. Another way to write that is with a capital R that looks like a paragraph symbol. 2 lines and then an R. That's the symbol for all real numbers. Let's take a look at what the range is, the Y. So remember the Y-axis goes up and down. How far down does the graph go? Well, I look low and again I see arrows. So there's an arrow going down. How far high does the graph go? How far up? It stops here. It doesn't have an arrow to keep going up. 1, 2, 3, 4. So at 4 is where it stops. There's my range, going forever down. So because the Y values are going down and keep going down, that means it's everything less than this value. It's the less than symbol when we write our range. So we write the set because we are restricted, all Y such that Y is less than or equal to 4. It can get up to 4, but it can't go higher than it. So it's everything down, everything less than. When we see an arrow going down, less than. Let's look at one more example. Find the domain. So the domain is the X going right and left. Left, I see an arrow. Right, I see an arrow. So again, there's no restriction. I can say all real numbers or use my fancy R for all real numbers. Now let's take a look at the range. The range is the Y going up and down. Going down, I see this is the lowest point on the graph. 1, 2, 3, 4. -4. So -4 is the lowest it can go. But then I go up, 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 and what do I see? Again, I see arrows. So up, 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 and arrows go up. When it goes up for the Y, that means greater than, everything greater than -4. So my restriction is all the Y values such that Y is greater than or equal to -4. Let's talk about intercepts and zeros. The X-intercept is also known as the 0, the X-intercept or the 0. That's where the graph crosses or touches the x-axis. The way to write the 0 is as an ordered pair. Whatever the x value is, comma, 0. The y-intercept is not called a 0. It's just called the y-intercept. This is where the graph crosses or touches the y-axis. The way that that ordered pair is written is 0, comma, and whatever the y-coordinate is. Let's look at some functions to identify the x and y-intercepts of each function. Let's start with the x-intercepts, or the zeros. So remember the x-axis, horizontal. Here's our x-axis. Let's label it. Let's show where all of the x-intercepts, or the zeros, are, and then we write them as ordered pairs. Let's start with the lowest one. That's -4, 0. Because we don't go up any, it's on the x-axis. Another one is -2, 0. And the third one is at the origin, 0, 0. Now let's look at the y-intercepts. Here's the y-axis, goes up and down. Notice the y-intercept is a repeat of one of the x-intercepts. It's also 0, 0. Let's look at another. X-intercept, or 0, is a shortcut name for it. Here's the x-axis. Where does it cross the x-axis? Here at -1, comma 0. That's the only one in this graph. Now the y-intercepts. Here's the y-axis. Where does it cross the y-axis? There at 0, 3. See how the x-intercept has a 0 after the x value and the y-intercept has a 0 before the y value? X-intercept or zeros. Here's the x-axis, mark it. Here's the graph touching the x-axis. That's at 2, 0. The x-coordinate is 2, the y-coordinate is 0. Where does it cross or touch the y-axis for the y-intercept? Here it is at 0, 3. Notice the x is 0, the y is 3. Let's take a look at this one. It hasn't been graphed yet. We can use our calculator to graph some functions. Let's practice doing that here in y equals 3x minus 9. I'm going to go to my graphing calculator and I'm going to type y equals 3x minus 9. Then I'm going to go to the table of values. So second graph to go to my table of values. See how the x's start at 0? I can go up to get some more values, some negative values. So here I see 0, -9. I can plot 0, -9. I'm going to put a point there. Let's find some more. 1, -6. I can find 1, -6. Let's keep going. 2, -3. 2, -3. 3, 0. 3, 0. 4, 3. 4, 3. I've got room for a couple more. 5, 6. 5, 6. And 6, 9. 6, 9. And now I can graph my line. I'll put arrows to show it would keep going if I kept going. Now I can find the x-intercepts or the zeros from this picture. See the x-axis? Where does it cross? Right here at 3, 0. I can also use my table. Remember that the x-intercept is where the y is 0, so 3 goes with 0. 3, 0 is my x-intercept. Now it's time to find the y-intercept. Remember, that's where the y has a number and the x is 0. If I use my table, where's the x 0? Here at 0, -9. If I use my graph, where does it cross the y-axis? Same place, 0, -9. Take a moment to use your own words to describe the similarities and differences in domain, range, x-intercept, and y-intercept. See you in class.